Hello, and I guess this is time for finishing up with the Napari plugin foundation grant for creating the MTrack plugin, which uses VollSeg segmentation to segment chemographs and then do Ransack fits on them to get the dynamic instability parameters of microtubules. Now, I verified different features of the plugin, and it's only missing the tests which it has to write for fulfilling the grant requirements, but it's already in production, which means that I have given it out to researchers to use it on their data and get the analysis. So I'm just going to show you with the steps which I expect would help you to analyze the dynamics of these microtubules in different experimental conditions. So to start with, get your plugin from the Napari plugins hub. It will show up in the install plugin menu, and then click on MTrack after it has been installed. And now let's say you have done experiments on microtubules and you have obtained chemographs which are like hundreds, and you have put them in one directory with plus and minus and separate. So you're going to open that folder, and my folder is test microtubules, and it's going to give you this option. Now why it's giving you this option is because when you make these chemographs of the microtubules, then the size of these chemographs is different. But now I want to stack them all together to make them into a time lapse. And then once I stack them together as a time lapse, then it would appear as a fake time lapse in the Napari's menu, which is good interactivity because then you can go back and forth and see for which particular chimograph how good the fits and if you have to change something. And so for this, you have to choose the reader function that I have built in to do so. And then see these chimographs appearing as a fake time lapse, or we could call it a file lapse, right? Is the number actually corresponds to the number of file. And then you have the calibration of your microscope in space and time over here, which you can adjust. You have these three tabs where you have the parameter selection for the Ransack fits, which is kind of like a smart regression. Then you have the plots which will appear here, and you have the table. And now the reason that you have these three buttons is because if you open your folder of images, you first just want to take the default parameters and hit run and see what else you get. Only thing you have to be careful of here is that you have to specify the axis, which is time. In this case, my time axis is y, so I've put 0. But if your chimograph is flipped, your time axis could be x. And this is important because I am kind of sorting the coordinates along this axis, so I can give you fits which are sorted by time. So that's why it's important to actually make that selection. And why the three buttons? The run button is to run all of these uh, files with the default parameters. The green one is to use Ransack with changed parameters, but only to correct one particular file and not affect all of the files. Because let's say you have five files, out of which one or two files are not giving you a correct results, and you just want to correct them and not affect the results which you are already happy with. And you are again going to use the recompute file current file fits, the green button, to recompute these fits with either the same or the changed parameters. And if you're still not happy, you can remove all of the fits that the program is giving you. You can remove the segmentation which the program is giving you. And then you can draw your own fits using the shapes layer of Napari, which I will show you how to do. And then to tell the program that you want the growth rates to be recomputed, you will press the orange button. Step 1, what you do, open your folder. Now what? Hit run, right? It's going to show you the progress bar on which file it is, and it's calculating segmentation, and it's doing these fits. Segmentation is in brown, and if you see some segmentation mistakes, for example here, you can use Napari's layers of labels to remove that. You can use the recompute current file button to recompute the Ransack fits. If you're still not happy, you can hit it again and hit it again, and once you are happy, then you say it's fine, but I'm not completely happy because this doesn't looks like a proper fit. So I'm going to remove this, and I'm going to make my own fit here, my own fit here, and my little fit here. And now how do you tell the program to recompute? It's this orange button, and then the program will recompute it. And now let's look at the table. The table is interesting here because first it shows you all of the growth rates, and the shrink rates actually appear in the bottom, right? And on the other columns, they are the start and the end time of the events. There is the catastrophe and rescue frequency for each of these events. So let's say, for example, in file 1, let's go to file 1. If you just click here, you are going to go to this file, and you will see, okay, this segmentation doesn't look right, so I'm going to remove this one. But the reason that there are 3 entries for file index 1 is because there are 3 events that the program has found. It can be wrong, so you recompute it, and it's only going to recompute this current file. And now you say, aha, now I'm happy. Now my file number 1 has only so it's like my file index only has now 1 growth event, and so I'm happy with that, and which is over here. Yeah, it's just 1 growth event. And now you can go to this file and you say, okay, this is also a bit messed up, probably because the segmentation is not right. So you can do this, you can recompute this. I say, still not good. No. And if you just get fed up with what fits the computer is giving you by default, you can say, I am just gonna remove all of this. Just looks like much easy if I just do it by hand, right? For example, I can see, since I'm an experimentalist, I know I have to do it like this. Maybe I have to do it like this, and then I have to do it like this. And these are the kind of little experimental details which only a biologist would know. So you can do this, and then you can hit on this orange button. And now this was file index 0, so the changed values are here, which you can see here. These are the new shrink rates, and the growth rates appear here. So they are appearing in the bottom. And now these are the calibration settings, right? So if you change this, it's going to actually change your results, because this is growth rate is nothing but delta x by delta t, which are the calibration units which are multiplying your pixel level answer. So if you change this, for example, if I change this to 3, it's automatically going to update the table. So that's the point. Yeah, so this is something that you know from your experiment. What are the calibration units? You set them before you do the analysis, and if somehow you make a mistake, don't worry, just change it on the fly. The table is going to update it, right? The Ranzak plots always contain these 4 plots, which are the growth rates, the shrink rates, and the catastrophe and rescue frequency. And if you're happy with the analysis that the program is giving you, then you can just click on the save button, and you can save it as a PNG file. But let's say you say, I'm not really happy with this kind of violent plots because that's not my style. I want scatter plots. Yeah, so you can just save the table, and you have these columns which contains these growth rates, shrink rates, and start end time, and the frequency information. Right click on this and save it, and then save it as a CSV file in whichever location that you want. And that's it. And then you have analyzed the whole set of microtubules. uh, Now it's out for testing. So now I'm expecting people to give me feedback on how they feel about the UX design, about the performance, and I'll make some test cases to handle the programming side of it and the algorithmic side of it. But for now, you can get it from the Napari Hub, and try out this version. I think it's 1.3.3, which is the latest one on the hub. Yeah. So try it out on your microtubules and then give me feedback, and then I'll be happy to answer your questions either on GitHub or on Zulip or in other forums that you may want to ask these questions, like the image forum. So have a weekend, and it's a pleasure to make MTrack in Python for Napari. Yeah, that's it.